Hello there, math fans. The students asking me a question on the discussion board. And really what it highlights is this challenge of working with unknowns. So I was going to say a few general things about that piece, and in doing so, I'll answer the student's question. Please let me know if you have follow-up questions, but I hope this gives a deeper understanding. So the question says, assume you have the equation of a line, and then it says that m is negative and b is positive. And that was something that came up in office hours. Students were like, what does that mean? It does mean it's a negative slope. It means it's going down from left to right, and that it has a positive y-intercept. And eventually you'd like to be able to kind of have a picture of that in your mind. I've learned over the years that there's a lot of things I do, and so I've started to try to be more explicit about it, where I draw a picture, or I think of a picture, not so much to solve the problem, but just to give my brain something to chew on. So in my mind, I was thinking, it has a positive y-intercept and it goes down. Now, how steep do I know to draw it? I don't know. That's the picture that popped into my mind about this story. Okay, separate from that, the question asks for this area. And so it's a symbolic question. A bunch of students say, I just don't understand that at all. What do I do? How do I work with things? And so my one bit of advice, this is sort of my general advice for problem solving in general when there's unknowns. When you will get better with time, it comes with practice. But the first few times you do something, or you're trying to find a pattern, or you're in a new location, I argue for 3 examples. What I mean is this. I would just make up, 3 is usually overkill. By the time a student has done 3 examples, they see the patterns. That's my experience. But just do 3 simple examples. Here's 1. I'm just making up some numbers. I don't know, here's 2. And you could just change like a number or 2. Here's 3. It's kind of, if you make the numbers 1, sometimes it's too hard to see the pattern. So let's do something like this. There's 3 examples. So what I mean by that is you could find the area you get from this one. And some students it takes a while for that level of abstraction, that maturity of sort of mind and understanding to do this. And it's not a bad thing. I do this whenever I'm stuck. It's something we don't often teach enough. But if I was going to draw the picture for this, it would intersect. And this often answers those subtle questions. It's one of these subtle questions that's happening here. This would look like this. This would look like this. And I feel like even the moment I start to write one example, things start to become more clear to me. That this height, so now I feel like I can go back here. Last quarter, the student complaining, they said, sometimes you do multiple questions at once. Stop doing that. But I feel like it gives you some common themes. They were really mad. They wrote something like a mean comment on my rating and said, he does a bunch of different questions at once. I said, I appreciate the feedback, but I wasn't doing it to be mean. Okay, now let's get this other side. I shouldn't laugh about it. They're probably watching this, swearing my name now. This is the game we're playing. And you can see by having the examples, some of that weight of thinking of unknowns goes away a little bit. So if a student was saying, but it takes a little bit of time. If a student was saying, well, I need to know that to find the area, or I need to know that, or I need to know that, we're going to figure out when this is 0, or when this is 0. And by doing the examples, you learn even more, I find. Sometimes I think mathematicians miss this. We're so used to going to the general formula that we don't realize there's values in examples. I find when I do an example, it tends to give me more questions, interesting questions. So if you were somebody that wanted to know how I'm coming up with interesting questions, partially it's just because I like to do lots of examples. Doing examples gives me interesting questions. That's a lesson that I think strong mathematicians sometimes forget. Okay, so we're going to subtract 6 from both sides and divide by -2. Now, there's lots of negatives there. There's going to be -6 over -2. Oh, it ends up not being negative because it's a 3. And so that first triangle, and maybe I'll zoom this out a little bit so I can make some summary comments. Apologies for planning. As normal. Okay, so the area is 1/2, the base is 3, the height is 6. I might just leave it like that for a second. So there's one example in our toolbox. Oftentimes the second example just confirms what we saw. We'd put a 0 here, we would then subtract the 6. So this is 3 examples to get your footing. And I didn't learn this in grad school. Sometimes I go back and look at some of my notes from grad school, some of the research, and I realize like I did like 10 pages of work and I never did an example. And everything I did didn't make any sense. Because I had not learned the lesson that you should do some examples before you dive deeply into some theory. Okay. Again, hard lessons I learned that I'm trying to pass on. 1/2 base times height is this. 1/2 base times height is this. All right, last one, just to sort of, I feel like the third example just sort of solidifies your machine, so to speak. Okay, I'm subtracting. I get x as 1/2. Well, -2 over -4. So I get that the area is 1/2 times 1/2 times 2. Okay, so now I have a very fertile testing ground. Now let's come back to this problem. Again, that's not the fastest way to do the problem, but it's the way to do it so you completely understand it. Okay, so now we're going to come back here and do the same thing. I need to know when this is 0. I'm going to subtract the b, so it's going to be -b equals mx. And I'm going to get x is -b over m. And that sort of bugs me. I'm like, what? Why am I going to label this -b over m? And that's what the people in the discussion board are asking about. They're like, why would that have a negative there? It didn't have a negative here. Ah, this is where it's helpful I have these examples down here. Why wasn't there a negative here? Well, it's fertile ground now. This was my m. The negative was contained in the m. This was my m. This was my m, the -4. See, I should have written it this way. So even though there's a negative on top, because m is negative, this is a positive number. That's sometimes really hard for students, but it's easier if you have the examples below. Because m is negative, you don't have to account for that or change anything. You just have to not be bothered by it. Okay, so the area is 1/2. The base is -b over m. Again, that negative bugs us, but we just talked about it, times the height, which is b. If I clean all that up, it's -1/2. And I'm doing a lot of this problem, but it's because I feel like it's a really valuable lesson. Then you go, hold on, there shouldn't be a negative. Once again, you go down to your examples and you now can run experiments. So one thing that's really nice about math is you can do experiments with pencil and paper. So if this is b and this is m, m is -2 here, and this is b, and you plug all that in, you don't end up with a negative. You get -1/2 b squared over -2, you get 9. That matches this. This is the right formula. There should be a negative here because there's a negative here. But you see how doing examples allowed me to test that instead of trying to guess or undo it or drop it. So it's kind of a bigger mathematical lesson. I think I've been making the case that it's a lesson that people at all levels of math sometimes forget, including myself. All right. I hope there was some value there. Let me know if that clarified anything.